It's the most wonderful time of the year, Christmas. And what better way to get into the holiday spirit than with a Minky Couture blanket? Whether you're gathered around the tree with loved ones, roasting marshmallows by the fire, or just looking for a cozy way to stay warm on a chilly night, Minky blankets are the perfect addition to your Christmas festivities. With a wide range of festive designs and colors, you can find the perfect blanket to match your holiday decor or gift to your loved ones. So this Christmas, make your holiday even cozier with a Minky Couture blanket. Head to minkycouture.com now and find your perfect blanket, just in time for the holiday. Happy holidays from Minky Couture.
Attention car shoppers. Right now at South Carolina Federal Credit Union, you can get a new or used auto loan and pay nothing until 2024. And no payments for 90 days means nothing out of pocket going into the new year. Plus, we have flexible rates and terms, so you could make the best financial choice for you. Learn more at scfederal.org/auto loans. That's scfederal.org/auto loans. Certain restrictions apply. Existing South Carolina federal credit loans are excluded.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello once again, and thank you for joining us on this, the Space Nuts podcast, episode 196.5. No, it's 196, but when we get halfway through, it'll be 196.5. Joining me, as always, is his good self, Professor Fred Watson, astronomer at large. Hello, Fred.
Hi, Andrew. Good to talk to you again. Andrew Dunkley, broadcaster at large from Dubbo.
Yes, and broadcasting from my home as of this week.
That's pretty impressive.
Yeah, so, I mean, you've been in isolation for a bit longer than me. This is my first couple of days.
Yeah.
But you know what I've discovered is, because I'm doing two jobs, I do the radio job and then I do the Salvation Army job. I've got both sets of computers and I've got 4 screens here and work phones. It's mayhem. But I'm finding I'm more productive. Because when I'm on the radio, I can't answer the phone, obviously. But while I'm doing it from home, and we're doing it kind of in a semi-automatic way, which sounds bad, but it does work, I can answer the phone between segments, and I've been doing both jobs from 6 o'clock in the morning. It's bizarre, really bizarre. This new way of life.
Be careful who you say that to, because they might say, oh, he's doing 2 jobs at once. We'll halve his pay.
That'll happen anyway.
Yeah.
That will happen. There's certainly been an impact here regarding COVID-19. My wife's position has been frozen, so she's been stood down. So we've got to deal with that. Don't know how much longer my other roles will last, but we'll keep the podcast going, Fred.
Yeah,
if only to alleviate boredom.
Exactly.
So let's go through the topics of the day, or the topics of the week. And this collaboration between Airbus and the European Space Agency looks interesting. In fact, they've been successful in commissioning the CHEOPS mission, which we will obviously learn more about. We'll also talk about these medium-sized black holes, because they were thought to exist, but we'd never seen one. Now we've discovered one or two, and Hubble has found the best evidence yet of mid-sized black holes. And you can't get away from it. Swinburne University has a COVID-19 symptom tracker. So I think it's a satellite. It uses laser technology to take your temperature. I don't know. We'll talk about that. And some questions. This question, Fred, I think is very astute, very thought out, very, very, very clever indeed.
Here we go.
Chris is asking, how do comets have tails? How, not why. How? Because he's like some people, I imagine, confused about the vacuum of space enabling that. And then there's this really dumb question from some loser moron wanting to know how humans would adjust to living on Mars because it's got a longer day.
I wonder who that could have been.
He tells me because I talked to myself, that he was watching The Martian again the other day and got to thinking about settling on Mars and how humans would adjust long term to having a near 24.5-hour day.
Yep.
So let's tackle that one. I think that's question of the year so far myself.
Well, it obviously is that.
Yes.
When we start asking each other questions,
it secretly means there's no audience. That's what that means.
Exactly. I think it's telling us something. But we always welcome your questions, dear listeners. And Andrew,
I'm just hijacking the segment.
Yeah, he just muscled in. That's all that's happened.
Couldn't help myself. Well, I do. It's the journalist in me, Fred. I can't help it.
Well, it's good. It's good that you've still got that instinct, Andrew.
Yes, it's there, all right. I'll tell you what an instinct it is. I drove past a motel the other day and they had a big sign in the driveway, no vacancy, but there was not one car in the car park. And I thought, that's got to mean something.
Yes.
And there was two answers to the question. There's absolutely no tourism, so what's the point? Or the government's paying them to use it as an isolation ward.
That's interesting.
Yes, I'm still pursuing. Yes, let's get down to business. Airbus and the European Space Agency, ESA, have got in bed together and they have successfully commissioned the CHEOPS mission. Now, I gather that this is the first time that Airbus has basically done this exclusively with ESA, something to that effect. I read the media release and I fell asleep several times. So I think you better take over here.
Well, look, it is, in a way, it's a story that you wouldn't normally talk about because this is a routine part of putting something into space, and the handover from the contractor who's put the object into space to the operator of the satellite is a formality, and it's big news within the industry. Maybe not so much in the wider world, but the reason why I highlighted this was because I think this spacecraft itself is very interesting to talk about, and really just celebrating the in-orbit commissioning is just giving us an excuse to talk about it.
Fair enough.
I think it might, I'm not sure about this, Andrew, but I think it might be normally pronounced CHEOPS.
Okay.
Because it's named after an Egyptian monarch from ancient times. But it is.
I grew up thinking that the pronunciation was CHEOPS, but
yeah, it might be. You might be right.
It could just be an Australian thing, mate.
Yeah, well, yeah. I might be doing the wrong thing by turning it into a Greek word, but the bottom line, it doesn't really matter how you say it because it's actually an acronym.
I figured it would have been.
Yeah, so CHEOPS is as good as anything. But actually, maybe the acronym gives us a little bit of insight because it stands for Characterizing Exoplanet Satellite. And of course, it's the CH in characterizing that.
Yeah, that's a stretch. That
starts it up. So anyway, and that tells you the story. The spacecraft is a joint venture between ESA, the European Space Agency, and the Swiss Space Office. In fact, it originates, I think, in the University of Bern in Switzerland. I think they were they're the Centre for Space and Habitability at the University of Bern is the lead institution for the project. And the name is, characterizing exoplanet satellite really tells you exactly what it's doing. It's a box about 1.5 meter cubed. It has a hole in the side for a telescope. It's a 12-inch telescope, 30 centimeter telescope, equipped with a very sensitive image sensor. The kind of thing that we've got in our mobile phones and our electronic cameras. This one is very, very sensitive to small changes in illumination. So you get an image, but each pixel of that image gives you a pretty accurate readout of how much light is falling on it. So, and that's the whole point. So what the mission is about is to observe stars which are known to have planets going around them. And not only that, these planets are ones that transit across the face of their parent stars. So, for example, stars that have been discovered by the Kepler mission to have planets, or stars that have been discovered by the TESS mission, the current one, to have planets. These are the candidates for further examination by CHEOPS. And the idea is that those transits of the planets in front of the star will be observed in very fine detail, with sort of microscopic precision, if I can put it that way. And so the mission is all about making accurate measurements of the diameter of these planets, because that's what you can get from these dips in brightness, and to make as accurate a measurement as possible for each of these planets as it transits regularly across its parent star. And then to combine that with data from the Doppler wobble technique, this famous method where you look for the wobbling of the star as it's pulled slightly out of position by the planet orbiting around it, because from that you can get the mass of a planet. If you've got the diameter of a planet and its mass, then you can get an accurate estimate of its density, and that gives you a clue as to what it's made of. So CHEOPS is specifically targeting planets in the range Earth to Neptune size, and that's a really interesting region, because Earth is a rocky planet, Neptune's a gas giant. Where's the delineation between them? How many of these exoplanets is one or the other? So that's the idea.
We know theoretically how big a rocky planet could be before it's not capable of being a rocky planet.
Well, that's right. I mean? Yeah, I think that's true. I think the planetary science specialists do have insights into that, because if it gets, I don't know, it depends very much on whereabouts in a planetary system it's formed, and the rule is pretty well what we see in our own solar system. You tend to find the rocky planets formed nearer the parent star, gas giants further out beyond what we call the ice line, where where ices can condense out or freeze out. But we also know that planets move around in their orbits. They might start off in one orbit and end up in another. So there's all this stuff goes into the mix, and having measurements of the density of a wide selection of stars, or planets around stars, I think is going to be a very valuable tool when CHEOPS completes its mission, which I think is about 3.5 years, if I remember rightly, the mission length. So we should see interesting things coming from it. And just returning to the excuse for running this story, yes, Airbus was the company that basically put the spacecraft into orbit and has done the in-orbit commissioning. And I assume that what's happening now is that the control of CHEOPS will be handed over to ESA and the Swiss Science Space Agency. I believe their Science Operations Centre is at the University of Geneva. So it's a really interesting mission coming from the Swiss, and we look forward to hearing some of the results from it.
Yes, indeed. I mean, if they're able to get much more detail about exoplanets, it stands to reason we may be able to learn about let's call it physiology of some of these worlds, and maybe even see whether or not some of them are capable of sustaining life.
Yeah, exactly. It's all adding to our store of knowledge about, this whole new regime of planets around other stars, which was unthinkable 20 years ago.
Yes, and now it's the numbers are just growing day by day. It's fascinating. All right, we'll keep an eye on that one. You're listening to Space Nuts with Andrew Dunkley and Fred Watson.
Roger, you're loud and clear here also.
Space Nuts.
Now, Fred, saying hello to our patrons, and we've got a Patreon question to answer later on, which you can hear as bonus material on our Patreon site, patreon.com/Space Nuts. And if you would like to join the Space Nuts Patreon fraternity, you can do so at that site. for as little as $3 a month, but you can set your own limit. And we do, as always, want to say thank you to our patrons for supporting the podcast financially. It's not essential. We're absolutely not saying you have to, but if you want to, that is wonderful and totally up to you. But patreon.com/spacenuts if you'd like to inject a couple of dollars into the maintenance of the Space Nuts podcast. Now, Fred, we've talked about this before. Our timing couldn't have been better. We once did a segment talking about the fact that there are tiny black holes and massive black holes, but nothing in the middle. And then the week after that, we went, well, we've found one. It really did happen that way. And now Hubble has found the best evidence yet of a mid-sized black hole. This is exciting.
Yes, it is. You're absolutely right. To highlight this, the gap, the missing link, as it were. We see black holes that are not much more massive than the sun, up to maybe 20 or 30 solar masses. They're the debris of, or the remnants of giant stars that exploded in supernova explosions, and the core collapses to a black hole because it's got too much mass in it for the outward pressure of the atoms to resist it, and the whole thing collapses, and you've got a black hole. So that's what we call stellar mass black holes, because it's the mass roughly of a star. And then at the other end of the spectrum are these absolute monsters, the behemoths of the black hole world, which we find at the centers of galaxies, possibly at the center of all galaxies. So these have mass ranges in the millions to billions of solar masses. I think it's 4.1 million solar masses is the mass of the one at the center of our own galaxy that we see manifested in radio radiation with the glorious name of Sagittarius A star. That's the radio source at the center of the galaxy. So the puzzle has always been, first of all, why don't we see anything in between them? And secondly, how do these big supermassive black holes get so big? Because that's not easy to understand. If you look back to the early history of galaxies, maybe 12 or 13 billion years ago, were there supermassive black holes then around which the galaxy formed, or were the galaxies and the black holes growing at the same time? And in fact, that's the picture I think that we have of the way these things work. So this story actually goes back to X-ray telescopes. The Chandra X-ray Observatory, which is a NASA orbiting spacecraft, and the European Space Agency, they have something called XMM Newton. I always wondered what XMM stood for, but it's X-ray Multi-Mirror Mission, which means it should be XMMM.
I would have thought so.
Yeah.
Ran out of ink.
Maybe that was it. Yeah, too many M's. XMM Newton is it's a high efficiency X-ray telescope and optical monitor, all of the fancy stuff. So what you're looking for is an X-ray flare that has specific characteristics that suggest it might have come from one of these intermediate mass black holes, as they're technically called. And the group of scientists who've been carrying out this study, if I remember rightly, they're based at NASA. Actually, it's a good point. Actually, no, there's a European content. One of the team members is Nathalie Webb of the Université de Toulouse, which is in France. So an international group. They looked for the flares, and they found one. Something that looked as though it might have come from an intermediate mass black hole because of the sort of profile of the flare, the spectrum of the flare, things of that sort. So how do you prove it? And what they did was they applied for some time on the Hubble Space Telescope because these two X-ray observatories, or the one that had produced this flare or revealed this flare, actually had a fairly precise position for it. And so you can use the Hubble then to home in on the origin of the X-ray flare. And it turns out to come from a star cluster around a distant galaxy. It's a galaxy. I don't have its distance to hand, but it is clearly a galaxy whose distance is measured in billions of light years. It's a long way away.
It's a galaxy far, far away, Fred.
That's the technical term. That's absolutely right. It is, but like many galaxies, it has an entourage of these what are called globular clusters. We've got about 100 in orbit around our own Milky Way galaxy. They're clusters of stars, tens to hundreds of thousands of stars in each globular cluster. And we think that they're the remnants of the cores of dwarf galaxies that have been kind of stripped of their outer stars by the gravitational pull of our own galaxy, or the parent galaxy, the galaxy that these things are going around. So that is where the flare came from. And the fact that it's located in one of these stripped down cores of a dwarf galaxy tends to support the picture. They actually consider that to be the clinching piece of evidence that what we found is a flare coming from an intermediate black hole. Because it's, as I said, it's commonly thought that these globular clusters are the cores of stripped down dwarf galaxies, but they also might well be perhaps the food on which a supermassive black hole feeds. In other words, an intermediate mass black hole in a globular cluster might eventually wind up being accreted or absorbed by the black hole at the center of the galaxy, causing it to grow even bigger. And so the picture is that that's how supermassive black holes have grown, by swallowing up the black holes associated with these dwarf galaxies. Sorry, Andrew, you're going to say something. I was
going to say, so could that explain why medium-sized black holes are proving difficult to find, because they've been consumed?
They've all been consumed, that's right. Yeah. And, what it suggests is the heart of globular clusters are good places to look for intermediate mass black holes. Now, as I mentioned, there's 100 in orbit around our own galaxy. We know that the stars in them are among the most ancient stars in the galaxy. They're very old. There's because these things orbit around, not in the plane or the disk of the galaxy. They orbit around the galactic center, but at all kinds of weird and wonderful angles, which tells you that they belong to what we call the galaxy's halo. So these things orbiting around, because of where they are, there's no residual hydrogen gas there. That's all been gobbled up. Most of the gas is in the disk of the galaxy. And that's why it might be why we don't often see a flare coming from the black hole in one of these things, because there's no gas there. You've got to rely on a passing star falling in to get the flare. And that might be quite a rare event. So yes, it all feeds into a bigger picture that suggests that is how, exactly as you said, how supermassive black holes grow, by gobbling up smaller ones.
Okay. No doubt there'll be more to learn from this, and we will we'll keep an eye on it. I imagine we'll get questions, Fred. People are fascinated by black holes, and every time we talk about them, the questions just cascade in, which is fine. That's what it's all about. We're happy to throw that all on Fred. I'll just sit here and smile. Now, Fred...
Well, you've got a nice smile, Andrew, I have to say. It's a pity that listeners can't see that.
It was my birthday this week, by the way.
Oh, many happy returns.
Thank you. I've got to tell you this lovely little story. I don't usually talk about my birthday, but my grandson, who is 5, was with his grandmother the other day, because we're keeping our circle of people down to Judy, myself, my son, my daughter-in-law, and the 3 grandchildren, and that's it. We're not seeing anyone else. Judy asked Nathaniel if he knew it was going to be my birthday tomorrow. So this happened on Monday. And he said, "I am aware." And then she said, "And how old will Poppy be?" And he said, 16. Judy said, no, he's going to be 58. What comes after 58? He said, I don't know. And Judy said, 59. And then he went, and then he'll be 100. Just like Fred. No, he didn't say that bit.
That's you fixed.
Oh, it was so cute. Kids are fantastic. Now, let's move on to something not so fantastic. COVID-19. We wanted to briefly talk about this one. There's a symptom tracker that has been created by Swinburne University, from what I can tell.
That's exactly right. You might wonder why we're talking about this on a Space Nuts podcast, but this is the. Hang on a moment. I can't do that.
Live radio, folks.
Yeah, sorry. That's all right. I've got you back, Andrew. I just went into a presentation that I was doing last night in the webinar, the Cosmic Relief webinar, because I wanted to see the image that I put in there, which has all my cheat information on the symptom tracker.
It's called preparation, Fred. That's what
it is. Preparation, slightly too late. So there's a public health group or faculty, at Swinburne University. This is Swinburne University of Technology in Melbourne, but they have also a very strong astrophysics and astronomical data computing facility. And what's happened is these two groups have got together and used they've devised this symptom tracker, which is not a satellite measuring your temperature, despite what you were saying earlier, Andrew.
Well,
it's a questionnaire. It's an online questionnaire, and you can just click on it, and it asks you, a few really simple questions. Basically, how are you feeling? Are you too hot or too cold, or what's happening? Have you got any symptoms?
So I could click on that right now.
You can. It's called beatcovid19now.org. That's the link. Okay. But what I was going to say is that...
I'm stopping right now. First question, what is your age? Where's the none of your business button?
It's 100 years old. Your grandson told you.
That's right.
That'll be next year. So it's what they do with the data that has the astronomical connection, because they're using astronomical algorithms, that the statistical algorithms that we use in astrophysics, which are often trying to glean information from really disparate data and essentially tease out the fine details. And so the idea with the symptom tracker is to do that, to look at where these hotspots might be, where people might be in an area that has more people suffering from COVID-19, the disease, than elsewhere. So it's called, as we've just said, beatcovid19now.org. That's how you can find it. And I'm sure Swinburne University of Technology will be great if you would participate in it.
Yeah, I'm doing it right now. I'm clicking through all the symptoms. You can probably hear me clicking away. I've nearly finished.
There you go.
Since this time yesterday, have you had difficulty getting out of bed? Strangely enough, no. Leaving home, no. It's preparing meals. I don't do that. I will finish this off because that's a big question. I'll get back to that later. But it's really quite simple. It's a good idea. Yeah, so far, over 14,000 people have completed the symptom tracker.
Yeah. So it's taking off, which is great.
Yes.
We need to get. I'm not part of this at all, but I think for the team to get the best results from it and the most useful results in terms of public health and planning and things like that, you really need the maximum number of people to engage with it. So it's a question of getting the message out, which is why I'm talking about it today, Andrew. And I'm very impressed that you can multitask to that level. Do a questionnaire while you're talking to me.
Yep. And the URL is beatcovid19now.org.
Indeed, it is.
It is. All right. You're listening to Space Nuts with Andrew Dunkley and, of course, Professor Fred Watson.
0G, and I feel fine.
Space Nuts.
Hello to all our Facebook followers. The numbers continue to grow as they do on YouTube. We've got 1,160 followers on YouTube now. If you'd like to follow us on YouTube, subscribe at youtube.com/c/spacenuts. The Space Nuts podcast group is doing very well on Facebook as well, and I occasionally pop my head in there. Sometimes people actually use my name in their statements to get my attention, and that happened yesterday, Fred, with a little bit of a debate over a word I used on the cover of my new book, The Turanian Enigma. Hang on, I'm just grabbing it. Oh, I kicked the bucket. Here we go. So on the front of the book, it says, the last survivors of an extragalactic civilization arrive in Turanian space seeking a new home, but instead they face the threat of total annihilation. Now, at first I thought there was an argument over the spelling of annihilation, but it seems the issue is that it's a noun being used as an adjective or an adjective being used as a noun. I can't remember which. But you know what? I'm going to leave it. I'm going to leave it. I like it. I don't want to change it. And if you knew what a nightmare it was going to be to just change one word, you would. It's
okay, Andrew. It's grammatically correct.
Thank you, sir. I would take that. I would take that as gospel from an Englishman.
Of course, that's right. Yes. The ultimate authority in the English language.
Indeed, rather. Now let's get on to some questions, and we have one here from Chris. I love this question for two reasons. Chris is asking us a fascinating question, but he also works for NASA.
Yay!
I told you they listened to us. I told you they did.
Well, Chris does.
Yes. But no, I'm sure he just puts it out on Bluetooth to every department for us. I'm certain. Anyway, a question for the Space Nuts. Hi, my name is Chris. I work at MSFC NASA, but don't get your hopes...
Marshall Space Flight Center.
Okay. But don't get your hopes up. I work in facilities. We do building automation and energy management. It sounds exciting to me. I don't know why he thinks it's mundane and boring. You should try my job. Now, he wants to know, how do comets and or asteroids have tails? How, not why. Space is a vacuum, right? So what causes resistance to make it or them have a tail? Is it just from the outstanding speed or what? If this isn't good enough for your show, I understand. Maybe you could just give me a short answer on Facebook. No, it is more than it. No, it's adequate, Chris. It's adequate for Space Nuts. We were actually thrilled with the question. So there you go. We're going to ask it. And he finishes his little note by saying, anyway, love the show. Live long and prosper.
We'll do our best.
That's the plan.
Yeah, that's the plan. Thanks, Chris.
It's getting harder.
Yes. Yeah, well, it's getting harder, that's right. But it's getting harder to prosper. But living long is something that I hope we both achieve.
Yes.
Especially as you turn 100 the year after next. That'll be good.
Apparently I do.
Yeah. So it's a great question, too, because we think of things, like a meteor, which hits the atmosphere, burns up and leaves a tail behind it. That's exactly what they do. Sometimes a bright fireball leaves a tail that can last for quite a while. But the physical conditions are a little bit different in space. And I guess the main issue is whether space is a vacuum or not. Well, it is. It's certainly the average pressure in space is much lower than anything we can achieve artificially on Earth. But that doesn't mean it's empty, because there's a whole lot of stuff going through space, including radiation, light and heat, infrared, radio waves. They're all traveling through space. But more especially, there are subatomic particles traveling through space, and that's one of the things that comets interact with as they get near the sun. So a comet is this kind of iceberg, mountain range sized iceberg, although I suspect they're much fluffier than icebergs. They're not as strongly bound together, but there's a lot of dust in there. So when they feel the radiation of the sun, and this is really just the heat and ultraviolet, things like that, so the electromagnetic radiation, that evaporates the ice. In fact, it sublimes. It goes straight from a solid to a gas. It's excited by the subatomic particles of the solar wind, and so it turns into a plasma. And that's why we see the gas tail of a comet, why it glows. And it basically is it's not necessarily streaming behind the comet like the tail of a meteor, because the tail is always emitted in the opposite direction to the sun. And you can imagine that as a comet swings around the sun, that direction is changing very rapidly, particularly as it goes past the sun. That direction changes. And so this gas tail evaporates from the comet and actually usually gets a curvature because of the fact that it is moving around, moving around past the sun. So that's what we were talking about, Andrew, not very long ago. You and I talked about Comet McNaught, which had this spectacular curved tail in early 2007. So that's the gas tail. But the dust also forms a tail. Now, this is a tail which is just streaming out behind the comet, and that is illuminated by the sun's light. It's akin to what we call the zodiacal light, which is the dust of the solar system being lit by sunlight. And so the dust tail and the gas tail are often separate. They're often two of them. They're slightly different colors, and really it's just the dust tail that's in effect streaming out behind the comet, although once again it's moved by the radiation pressure from the sun. That dust tail is kind of shepherded in a direction more or less opposite the sun, but is separate from the gas tail. So there's some complicated physics there, and Chris is right to highlight it. The mechanisms of comets' tails are pretty interesting stuff, and of course as astrophysicists we can learn a lot about the comet from observing them. So thank you very much, and keep up the good work at Marshall Space Flight Center, Chris.
Indeed. Thank you for getting in touch with us. And, of course, we look forward to the naked eye comet, Comet Atlas in May, fingers crossed.
Yes, fingers crossed, but Northern Hemisphere only.
Well, I'll get to see photos. Well, we got the last really good one, so I suppose it stands.
Yeah, that's right. It's only fair. Yeah.
Yes. Now, moving on, this rather questionable question from a questionable individual. I don't know why I'm reading it to you because I know exactly what it is. And I just watched the movie The Martian the other day. Judy and I love that movie. I think we've watched it 3 or 4 or 5 or 6 times now. And it got me wondering about the Martian day, or one sol, as they call it, which is around 40 minutes longer than an Earth day, give or take. So I wondered if humans settling on Mars, if that ever happened, would easily adjust to the extra 40 minutes per day in terms of their circadian rhythm. Because we have grown up on this planet, we have evolved on this planet over thousands and thousands of years, and we are used to what a day is here. All of a sudden being thrust onto another world where the time changes rather dramatically in real terms, would it eventually become a grind for human beings on another planet like Mars?
It's a complicated answer. Yes. It's a kind of yes and no answer. and what I was going to say, I remember reading some years ago that the rover operators on Mars, and particularly with Spirit and Opportunity, the two that were there from 2003 onwards, and now we've got Curiosity from 2012. Soon we'll have Perseverance on Mars. But I remember reading that those operators actually work on a Martian day, which of course is called a sol. To distinguish it from an Earth day, and it is roughly 24 hours 40 minutes. But I checked up on that while we were waiting to get together a little while ago, because I just wanted to make sure that I wasn't talking rubbish. And indeed, it's not quite rubbish that I was talking, but it's not the case that these operators actually work on Martian days. What happened was, I think for Spirit and let me just check. No, Mars Pathfinder.
Oh, yes.
Which
actually features in The Martian.
There you go. It does. Yes, that's right. So the idea with Mars Pathfinder was that the operators would keep Mars time. They'd keep the sols, basically. And the plan was to do that for the first 3 months of the mission. But they only lasted a month because it was just too hard to to work, not so much too hard to work on Mars time. The problem was getting completely out of sync with Earth time.
Yes, I can imagine.
Well,
it wouldn't take long.
And it doesn't take very long. That's right. It's only a few days, and you're several hours out.
Out of sync, yeah.
In fact, by the end of, if he did do it for 3 months, by the end of that, the Earth's 2.5 days ahead of you. And so, in terms of your days and nights. And this was the difficulty. I think I'm right in saying that with Spirit and Opportunity, they did manage to keep going for basically for that first 3 months.
The way to do it properly would be to be closed off from
yes,
the world
exactly,
completely.
Which is what you'd be if you're on Mars.
Yes.
So the idea of the circadian rhythms being extended to basically accommodate that, I think that is okay, because it's similar to jet lag, basically.
Yeah, that's what I was thinking.
But to do it while you're in an Earth environment, I think that's the challenge. And so I would have been wrong in saying, yes, these rover drivers all keep Mars time, because they don't. But they might do for a period. In fact, it'll be interesting to see when Perseverance lands on Mars next February. It'll be really interesting to see what the situation is. Do the rover drivers actually stick to Mars time, to sols rather than days, for the first patch of exploration, or what happens? We can track that, Andrew, because that's something you and I can talk about.
Yes.
I would like to point you, though, to a really good source on this, which is an article published back in February 2015 by a journalist called, and I'm going to struggle with the pronunciation of his name, but I think it's Chmielewski. It's Chmielewski, and it was published in The Atlantic, which is one of these reputable online sites. It is called, and probably the best way to Google it, to find it, is to Google it or use your favorite search engine. The title is "Jet Lag is Worse on Mars." So if you follow that link, "Jet Lag is Worse on Mars," read the article. It's full of detail and it's very, very interesting.
All right. I'm doing a search for it right now, so I don't forget to do it.
Yeah.
And there it is, straight up.
Yeah.
Wonderful. Okay. Well, that answers my question. And
it does.
Thank you, Fred. I appreciate it.
Thank you. That's a great question, Andrew, and I'm glad you asked it, because I was under a misconception there.
Yeah. Well, we've all learned something. Wonderful.
Yeah.
And that pretty well wraps us up. Before we go, though, don't forget to visit the Space Nuts shop at bitesz.com/spacenuts. That's bitesz.com/spacenuts. I think all these links are on our show notes at bitesz.com/spacenuts. That's counterproductive, isn't it? But you can scroll around on there. You can listen to all our episodes through our website. It ain't the prettiest website in the world, but,
it's not the prettiest podcast in the world.
It's adequate, Fred. Adequate. There are links to a whole bunch of books and a big link to this really, really weird one with grammatical problems. So have a look at that. Plus our bits and pieces. I noticed the polo shirts haven't popped up yet, but apparently we've got the logo sorted out, so we should be ready to roll soon on that, and some caps, and I don't know what else. I think we're talking stickers too, which would be nice.
I'm into this. I haven't seen any of this stuff, Andrew. I should have a look at it, shouldn't I?
Once you get stickers, it's things are serious, Fred.
Yes, they are.
Stickers make everything deadly serious. It's just a joke until you get stickers.
I think it might still be a joke after this.
But thank you to everybody for listening, and thank you for your contributions. Keep your cards and letters rolling in. And thank you, Fred. As always, it's been a great pleasure.
Good to talk to you, Andrew, and look forward to the next time.
We'll see you next week.
See you later.
Now, where was I up to with this beat COVID-19 postcode? Oh, gosh. They want to know everything, Fred. They want to know everything.
Space Nuts. You've been listening to the Space Nuts podcast. Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at bitesz.com. This has been another quality podcast production from bitesz.com.